Number 75, we're asked to graph a function, find the intercepts, test the equation for symmetry with respect to the x-axis, y-axis, and origin. We're going to start by graphing the equation by hand. We're plotting some points, and then we'll check it with a graphing utility. So for the intercepts, the x-intercept, we set y equal to 0, and we solve this equation for x by factoring out an x. Now we see the difference of perfect squares. And we've applied the zero product property, so either x equals 0 or x squared minus 4 equals 0. Here is the difference of perfect squares. We'll apply the zero product property to each factor, and we'll solve for x. There will be 3 x-intercepts in this function. To find the y-intercepts, we set x equal to 0. There's one y-intercept. It goes through the y-axis at 0. So now, to graph this, we're going to start with a table of values. And here's our function. We're going to substitute -3 in place of x. And our y value is -15. So I know this graph goes through the point -3, -15. Now we'll put -2 in place of x, and the corresponding y value is 0. That's one of our x-intercepts. We'll put -1 in place of x, and my y value that corresponds is 3. When I put 0 in place of x, I get 0 for y, so this graph will go through the origin. The y value at x equals 1 is -3. The y value at x equals 2 is 0. The y value at x equals 3 is 15. So now we're going to plot these points, and then we'll draw the curve that goes through them. And from there, what we're going to do is look at the intercepts. We'll observe that the x-intercepts are -2, 0, and 2. We'll observe the y-intercept is 0. As far as symmetry goes, this is not symmetric with the x-axis or the y-axis. This curve is symmetric with the origin if any x, y maps to -x, -y. And so in this case, this curve is symmetric with respect to the origin.